Welcome to this tutorial on Azure Virtual Networks and VNet configuration. Azure Virtual Networks, commonly called VNets, are fundamental building blocks for your private network in Azure. They provide a secure and isolated environment where your Azure resources can communicate with each other, with the internet, and with your on-premises networks. Throughout this tutorial, we'll explore how to properly configure and manage these virtual networks to build robust cloud infrastructure. A virtual network is an isolated, private network within Azure that enables secure communication between Azure resources. Think of it as your own private network in the cloud, completely isolated from other customers. Virtual networks provide three key capabilities. First, they provide network isolation and segmentation, ensuring your resources are protected from unauthorized access. Second, they connect cloud resources securely, allowing your virtual machines, databases, and other services to communicate safely. Third, they extend your on-premises networks to the cloud, creating a seamless hybrid environment that bridges your data center and Azure. Every virtual network consists of four core components. The address space defines the private IP address range for your network using CIDR notation. Subnets are logical divisions within the VNet that help you organize resources efficiently. The region specifies the geographic location where your VNet resources are deployed, such as East US or West Europe. Finally, the resource group acts as a logical container for managing all related Azure resources together. Understanding these components is essential for designing effective network architectures in Azure. Let's examine a common address space example, 10.0.0.0/16. This CIDR notation defines your network's IP address range. The /16 indicates a 16-bit network mask, which provides a network range from 10.0.0.0 to 10.0.255.255. This gives you 65,536 total IP addresses to work with. The prefix length of /16 means the first 16 bits are fixed for the network portion, while the remaining bits can be used for host addresses. This address space falls within the private network ranges, making it ideal for internal Azure networking. Azure Virtual Networks use private IP address ranges defined by RFC 1918 standard. There are three primary ranges available. The Class A network, 10.0.0.0/8, provides over 16.7 million addresses, making it suitable for very large deployments. The Class B network, 172.16.0.0/12, offers approximately 1 million addresses for medium to large environments. The Class C network, 192.168.0.0/16, provides 65,000 addresses, perfect for smaller deployments. These private ranges ensure your internal traffic remains secure and doesn't conflict with public internet addresses. Subnets divide the VNet address space into smaller, manageable segments for resource organization. They are essential for creating logical boundaries within your virtual network. Subnets enable network security through isolation, allowing you to apply different security policies to different parts of your network. They help you organize resources by function or tier, such as separating web servers from database servers. Additionally, subnets optimize traffic flow and routing by controlling how data moves between different parts of your network. Proper subnet design is crucial for maintaining a secure and efficient network architecture. Here's a practical example of subnet segmentation within a VNet using the address space 10.0.0.0/16. We can divide this into three tiers. The web tier uses 10.0.1.0/24 for front-end servers that handle user requests. The application tier uses 10.0.2.0/24 for business logic and application processing. The database tier uses 10.0.3.0/24 for data storage and database servers. Each subnet has 256 IP addresses available. This three-tier architecture provides clear separation of concerns, enhanced security through isolation, and better traffic management between layers. Azure reserves 5 IP addresses in each subnet that cannot be assigned to resources. Understanding these reserved addresses is important for capacity planning. The first address, ending in .0, is the network address that identifies the subnet itself. The second address, ending in .1, is reserved for the default gateway that routes traffic out of the subnet. The third and fourth addresses, ending in .2 and .3, are reserved for Azure DNS services that provide name resolution. Finally, the last address, ending in .255, is the broadcast address used for network-wide communications. When planning your subnets, remember to account for these 5 reserved addresses in your total capacity calculations. Network security groups, or NSGs, filter network traffic to and from Azure resources using security rules. They act as virtual firewalls that control access to your resources. NSGs provide 4 key capabilities. Inbound rules control incoming traffic from the internet or other networks to your resources. Outbound rules control outgoing traffic from your resources to external destinations. The priority-based system evaluates rules by priority number, processing lower numbers first. Finally, NSGs support flexible association, meaning they can be applied at the subnet level to protect all resources within that subnet, or at the network interface card level for individual resource protection. This flexibility allows you to implement defense-in-depth security strategies. VNet Peering connects 2 Azure Virtual Networks seamlessly using Microsoft's backbone network infrastructure. This powerful feature provides several advantages. It delivers low latency and high bandwidth connections because traffic never traverses the public internet. VNet Peering works across regions and subscriptions, enabling you to connect networks in different geographic locations or even different Azure accounts. All traffic stays on the private Microsoft network, ensuring security and compliance. Most importantly, resources in peered networks can communicate as if they were in the same network, with no additional gateways or public IP addresses required. This makes VNet Peering an essential tool for building distributed applications and hub-and-spoke network topologies in Azure.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.